Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, my name is Bella Putriyani Rachman with NIM 2111079 from Civil Engineering Classic. I will present Delia Mawarni's thesis entitled The Effect of Combustion on Concrete String Using Fly Ash Mixture. This presentation is to fulfill the assignment for the final semester exam for the second English course with lecturer Reski Ramadhani, S.Pd. M.Hum. The mind map that will be presented now include abstract, introduction, literature review, method, result and discussion, and conclusion. Okay, first of all, I will explain the abstract. Fly ash was from burning coal with large CO2, which can improve the mechanical properties of concrete. This research used cement with fly ash F-type superplasticizer. The method used in this research is experimental research by conducting direct laboratory experiment. The test objects carried out in this research were 27 test objects with a total of 9 test objects for normal concrete, 9 test objects for replacement of 80% plus cement concrete fly ash 20% plus superplasticizer type F 9 test specimen for 60% plus cement concrete replacement fly ash 0% plus F-type superplasticizer. The test object burned at the temperature of 300 degrees Celsius for more or less 2 hours at the age of 36 days, after which the compressive strength was tested. Next, I will explain introduction. Concrete is a building material that has literally better fire resistance because concrete is a material that has low heat conductivity, so it can prevent heat from spreading to the inside of the concrete structure. To get concrete with high compressive strength, a low cement water factor must be used. However, if the cement water factor is too small, working on the concrete will be very difficult, so that compaction cannot be maximized and will result in the concrete becomes porous. This will result in the decrease in the compressive strength of the concrete. To overcome this, type F superplasticizer can be used, which can reduce water. To reduce the porosity of cement, additives that are pozzolanic and have fine particles can be used, one of which is fly ash. In this research, concrete was made by substituting some of the cement with fly ash. The addition of type F superplasticizer. Next, I will explain literature review. The first, definition of concrete. Concrete is a composite building material made from a combination of aggregate, water and cement, which function as a pillar and cement function as a binder. The second the definition, fly ash. Fly ash is formed from mineral material that change as a result of a coal burning process. Fly ash can be used as a cement substitute for the compressive strength of concrete. Use fly ash 15% for that concrete with the low strength. The third, post-fired concrete. During this process, alternating heating and cooling cycle will occur, which will cause physical and chemical phase change in the area. This will affect the quality and strength of the concrete structure. The compressive strength of concrete in concrete that is burned for too hot at a temperature of 300 degrees Celsius is 1.082 MPa, and there is a decrease. The compressive strength of concrete in concrete that is burned for 5 hours at the temperature 500 degrees Celsius and is 3.563 MPa. The fourth, compressive strength. Compressive strength of concrete is the ability of hard concrete to withstand compressive forces for a unit area of the concrete surface. In the implementation in the field, factors influence the strength of concrete. The compressive strength value of concrete is known by carrying out tests after the age of 3, 7, 21, and 28 days, which is a lot with compressive force until it reach the maximum load. Okay, I will explain the method. This research used cement with fly ash type superplasticizer. The method used in this research is experimental research by conducting direct laboratory experiment. Material testing of fine aggregate is carried out in the form, form of specific repetitive volume, weight, organic substance content, mud content, water content, and sieve analysis. For coarse aggregate, specific repetitive volume, weight, sieve analysis, water content, and wear check using a mechanic Los Angeles. Then, the compressive strength and phosphide concrete tests were carried out with variation with use fly ash. In this research, 27 samples were made with a cylindrical shape with dimension of 300 mm and a diameter of 150 mm. The type of test carried out is a compressive strength test with a carrying age of 7 days, 28 days, and 36 days. Phosphoric concrete is variation was then made into 3 samples. The material used include fly ash, cement, and aggregate from cellophane with a maximum nominal dimension of 25.4 mm. The main tool used are material testing equipment, casting equipment, slam testing equipment, and compression testing equipment. And, and next, I will explain the result and discussion. For material testing result, in this research, type 1 cement was used with a specific repetitive value of 2.39 kg as per meter cubic. Meanwhile, for specific gravity tests, data fly ash using data from testing results carried out in the civil engineering laboratory of the Malang State Polytechnic, which is worth 1.443. Based on the result of fine aggregate, it showed that the sand material is suitable for use as a concrete mixture, and the coarse aggregate from cellophane crushed stone is suitable for use as a concrete mixture. For mix design, the concrete mix design is calculated using the method adopted from ACI 211. Noun concrete mix material data age 7 and 28 days with concrete strength blend exceed 25 MPa with a slump value taken of 100 approximately 20 mm. Coarse aggregate has the maximum value nominal size 25.4 mm with an open dry weight of 1014 kg per cubic meter in solid condition. That the cement used has a specific gravity of 2.396 kg per cubic centimeter without additional air. For concrete slump test result or slump test, the slump test aims to monitor issue for of workmanship workability, also the homogeneity of fresh concrete mix with a certain viscosity. The table saw the table saw the same slump value occurs and the first and second mixture with a value of 110 mm, but in the third mixture there is a difference in the slump value, namely 120 mm in the fourth to sixth mixing. The slump was not carried out again because it was considered to have the same value. For for comparison of analysis result for each mixture based on this graphic, the compressive strength of concrete, the 20% substitute concrete age 28 days saw a lower compressive strength value compared to the substitute concrete age 70, namely 25.4%. While for post-part concrete, the substitution is 20% increase from 20% substitute concrete age 28 days by 15.1. Okay, and the last, I will explain the conclusion. Concrete with 20% substitution at temperature of 300 Celsius for part concrete experience and increase compressed to 20% substitute concrete age 28 day by 15.1. Concrete with 40% substitution at a temperature of 300 Celsius post-part concrete experience and increase compared to 40% substitute concrete at 80 day by 10.3%. Normal concrete at a temperature of 300 post-part concrete decrease compared to normal concrete age 28 days by 37.7%. Overall, post-part concrete with substitution fly ash and crease compared to substitute concrete fly ash without burning. So, it can be concluded that post-part concrete with substitution fly ash crease compared to substitute concrete fly ash without burning. However, if seen from the planning, this compressive strength value is not adequate. The use of post-part concrete can be used for purposes with a quality of less than FC 10 MPa, like weight concrete. Well, that's all the presentation. I as the presenter apologize if there any mistake during the presentation of the material this time. I would like to thank you and wassalamualaikum warahmatullahi wabarakatuh.